4.1, start of the new chapters. So let's look at the learning outcome first. Learning outcome is help you to check. So every chapter, madam will include the learning outcome. So to see which topic, which subtopic you are not familiarized, then you can revise, recheck, and do your revision. Okay, so 4.1 Lewis structure. So you want to draw the Lewis dot symbol. Okay, you need to know and also able to identify octet rules, describe how atoms obtain the octet configuration. So something linked to your chapter 2 and 3 as well. Okay, so in this chapter, in this subtopic also, we want to look at the formations of ionic bond, covalent bond, dative bond using this Lewis dot structure. And then after that, madam will guide you how to draw a Lewis structures according to the formulas given. Okay, there are several steps which is important for your 4.2 and a 4.3. It's like a basic concept. And then after that, you want to compare the bond length between single bond, double bond, triple bond. Calculations for formal charge and determine which one is the most plausible Lewis structure. And then you need to explain what is the exceptions for the octet rules. So we have incomplete octet, we have expanded octet, and also odd number octet. Okay, and last one, to illustrate the concept of resonance using appropriate example. So here is the list, quite a heavy topic. For the first one, if you're looking at your notes and also you watch the video that Madam asked you to watch previously from Miss Balkis, Madam will further explain into it. So the video is only for you to have an first overview. What is it about Lewis dot symbol? What is it octet rules? What is it the Lewis structure and so on. Okay, so Lewis dot symbol. So sometimes you're using the cross symbol, both are accepted. So valence electron represent using either you using dot or cross sign surrounding the symbol of an element. Okay, so element for sodium, we got Na, magnesium, we got Mg, and so on. Okay, and then it provide the informations for chemical property. So the chemical properties over here indicate how many valence electron are they. Okay, and then whether it's metal, non-metal, it will losing electron, accepting electron, or just simply share of electron. So that refer to chemical properties. Okay, so if you look at the table over here, we can see group 1, group 2, and group 13, no transitions element in this case. Okay, we are looking only S and P blocks element. Okay, so group 1, group 2, group 13, we have sodium, magnesium, aluminium, for example, period 3 elements. Okay, so sodium, we have one, what to say, one valence electron. So in this case, you're only using one dot. So Na with one valence electron and a dot. Or maybe some of the reference book, you can see something like this, using the cross instead of dot. So both are accepted. So if you got magnesium, 2 valence electron, remember our Hans rule, we place singly first before pairing up. Therefore, magnesium, we are having 2 valence electron. Please put them apart, separate. Okay, either using dot, or maybe I want to put it like this, accepted. That is also fine, as long as they are separated, 2 valence electron. Then aluminium, 3 valence electrons. Silicon, we have 4 valence electrons, so singly first before pairing up. Okay, starting from group 15, your fifth electrons is starting to pairing out. Therefore, you can see there is one lone pair over here. Okay, one pair and then 3 single electron. So it starts like this. Phosphorus, we got 5 valence electrons. So we got 1, 2, 3, and 4. So the fifth electron doesn't matter which one, which pair you want to put. So as long as the fifth electron starting pairing up. Okay, and then group 16, for example, sulfur, oxygen, we have 6 valence electron. Okay, and then it looks something like this. Or maybe if you want to put double pair over here and then another 2 single electrons separately. And then we have chlorine or group 17 elements, fluorine, iodine, bromine, also same things lah, 7 valence electron. And last one we have from group 18, our neon, for example, 8 valence electron. So in this case, it's already fully filled. Okay, so to remind you also, you will need to link back to the valence electronic configuration. So for example, sodium, we got NS1. Madam, put the N as the unknown first lah. If you already know the element, you can put 3s1. Okay, so this one will be NS2. This one will be your NS2 and P1 because 3 valence electron. 2 will be in S subshell. 1 will be in P subshell. Okay, so let's say if I want the chlorine one, the valence electronic configuration, including the period. So let's say we know already the period. It will be 3s2 and 3p5. For neon, neon is actually coming from period 2, yeah? So it will be 2s2, 2p6. So let's say you have no idea about the period, then you just put ns2 and p6. So 8 electrons all together over here indicate there is 8 valence electron. Okay, so all these informations are linked together to help you to draw the Lewis dot substructure. Okay, so the challenge for you lah, you can try to memorize the first 20 elements. Okay, to help you to familiar. Okay, if let's say madam asks, what is the valence electron for nitrogen? Anyone remember? Nitrogen, how many, where is it from? Which group? And then how many valence electron? Anyone?
Group 15.
Group 15 and 5 valence electron.
5 valence electron.
How about silicon?
Group 14.
Group 14, and there will be 4
4
valence electron.
electron.
Okay, so it will be good that you can remember which element from which group to help you to understand how many valence electron. Okay, so next one we want to talk about octet rule. So this one I think most of you have already familiar with the words octet. Okay, octet means you need to achieve the maximum 8 valence electron, except for helium and also hydrogen. Okay, other than hydrogen and also helium, because they can only form duplet. They only up until S1 and also S2. There is no P subshell for both of these elements. Okay, so the rest of them doesn't matter, oxygen, fluorine, nitrogen, the maximum you want to achieve octet is to achieve 8 valence electron. Okay, so either by losing or gaining or sharing of electron. Okay, so you can use transferring of electrons. So this topic, madam will explain in the bond formation in the next slide, I think. Okay, so just to let you know, to achieve your octet, you can either use the method transferring electron, okay, metal release electron, non-metal accept electron, or maybe sharing of electron between two non-metal. Okay, so this one is just an example for you, yeah? So in order to achieve this octet configuration, octet rule, there is 3 types of stability that you need to understand and be able to name it and give the electronic configuration. Okay, so first one is the one that you used before. We call it as noble gas configuration. That means your valence electronic configurations will look like the noble gas. Whether it is helium, whether it's neon, whether it's argon, krypton, xenon, group 80. Okay, so noble gas configuration. So for example, in this case, we use aluminium, proton number 13. Okay, in order to produce Al3+, we're losing 3 electrons. Okay, so after releasing these 3 electrons, we achieve NS2 and P6. Okay, look like the noble gas configuration. Okay, which is similar like our neon. And the second type of stability, we call it as half-filled orbitals configuration. So half-filled come from the words half-filled d subshell. Okay, so for the second and the third stability, the type of stability, it refers to transitions element because it involves d subshell. Okay, so for example here when we have Fe, we stand for your iron ataupun you belajar ferrum kan. Okay, so proton number 26. So if you want to produce Fe3+, losing 3 electrons, now you're achieving 3s2, 3p6, and 3d5. Okay, so 3D5 is half-filled d subshell. So we name it, okay, as the half-filled orbital configurations. So when you want to write the valence electronic configuration, you write as 3s2, 3p6, 3d5. Okay, or as general, it look like this. Okay.
Uh, so, madam, so basically speaking, the noble gas configuration is only for elements which is not transition elements, right?
Yes. So
So,
whenever you didn't see any D subshell, that it will means the element from S or P block.
if it belongs to D block, it's either half-filled orbital or pseudo noble gas.
Okay, you look at the electronic configuration will be easier rather than you memorize this way. Okay, you look at the electronic configuration. Okay.
Alright, noted.
Right. And then the last type of stability is pseudo noble gas configuration. Pseudo in the meaning here, it means kind of noble gas, but it's not exactly noble gas because noble gas don't have D subshell. Okay, so if you look at the example given here, we have zinc, proton number 30. After losing 2 electrons, you achieving 3s2, 3p6, 3d10. So, okay, so now S subshell, P subshell, D subshell, all fully filled. Kind of like noble, but not exactly noble, so we call it pseudo. Okay, pseudo noble gas configuration. That means all the subshell S, P, D are completely filled. So we call it as pseudo. Okay, so remember three types of this stability of ion. The most common one is noble gas configuration. And then we will use quite often for the noble gas one. Okay, so for the starting introductions over here, any question before Madam proceed?
Madam,
Yes.
can we compare the stability for the ions with different electronic configuration?
That means you compare between three of this type.
Yeah.
You don't have to because they are all stable. When all are stable, we can't compare them.
Oh,
Okay,
okay.
you
And
just
then,
you just need to classify whether which type they are. But in all means they are all stable. Okay.
then one atom only will they will only become one of the configuration, right?
Yes, exactly. Okay.
Okay. Thank you, madam.
All right. So
Madam,
yes.
so for the octet rule,
Yeah.
I want to ask about the configuration of sharing of electrons.
Mhm.
As we can see here, got two fluorines, right?
Mhm.
And also there's another configuration of which there's a single dash on
Okay,
line.
no problem. Hazim, this one madam want to explain over here.
Oh, alright, sorry.
Okay. Right. So this one, madam, want you to write together with madam, yeah? So when I'm writing, you also need to write onto your notes, or maybe you want to take out a new piece of paper. Okay. So we want to, since we already know what this means by Lewis dot symbol, what it means by the stability types, okay, and then what is the octet rule. So now we look at the chemical bonding. So bear in mind that chemical bonding, now we want to talk about ionic bond, covalent bond, and also dative bond. So first one, ionic bond, also called as the electrovalent bond. Okay, ionic electrovalence, they are equivalent. They are the same meaning. Okay, so for ionic bonds, it forms between your metal and non-metal. So in this case, it involves transferring of electron from metal, losing electrons, and then non-metal will accept the electrons. Okay, so the resulting electrostatic force is our ionic bond. Okay, electrostatic meaning the force between our positively charged ion from metal, the cation, and also the negatively charged ion for our non-metal. So after they accepting the electron. Okay, so this is the important point. So electrostatic force between force of attraction, electrostatic attraction, electrostatic force between cation and anion will form this ionic bond. So looking at the first example, we have lithium from group 1, 1 valence electron. So we only drawing this one, Li dot, or you're using Li cross. Okay, and then fluorine from our group 17, 7 valence electron. So if you look over here, lithium, transferring one of the electrons to the fluorine. So for ionic bond, very important that you need to show arrows. From where to where? From metal to non-metal. Where do you move this electron? So remember, transfer electron showing arrows. Okay, and then after you transfer the electrons, now lithium becomes lithium positive ion. So if you look at the products over here, Li, initially one valence electron, after losing, it has no valence electron already. So become Li positive. Okay, and then for fluorine, it's accepting one more electron. So if you look at this black dot, okay, the dot in black color is accepting from a lithium atom. Okay, so now it's already achieving your octet configuration. And then it forming F minus. So make sure you, when you're accepting the electron or there is valence electron, you put a square big bracket. Okay, this is the bracket to accommodate the ion. And then the negative charge we put on outside. Okay, so the forces or the bond between Li positive and also the F negative is your ionic bond. So if you look at the diagram over here, it is very close next to each other. Li plus, Li positive and F negative, they are crossed by each other, next to each other. Tak ada separations lah, dia memang dekat. So, ini adalah contoh untuk lukis dia punya bond formation. So, the question will say, show bond formation. That means you need to show this process. Okay, so in terms of explanation, lithium, you just describe the process only. Lithium loses one electron to form Li positive. So, you need to mention what is the ion form. Okay, and then this electron is then transferred to fluorine, accepted by fluorine. Okay, and then fluorine becoming F negative. And then you mention what bond is formed. So the electrostatic forces between our cation Li positive and F negative, the anion, forming the ionic bond. So must mention metal become what ion. Okay, the non-metal become what ion and what forces are in between them. So let's just try the example here. So now, question number 1, by using Lewis dot symbol, show the formations of barium chloride. So from the formula over here, you know that Ba, there's one Ba atom, and then there's two Cl atom. Okay. So can anyone tell me what is the valence electron for barium?
2.
2. It is from group 2, so there is 2 valence electrons. So we separate it. Okay, remember how Hans rules law, we separate it. Okay, and then there will be 2 chlorine atom. So we write another 2 chlorine atom over here, Cl, Cl. So chlorine, how many valence electron?
7.
7, yes. So remember your Hans rules. We have singly first before pairing up. Okay, so you can do it for both. Okay, so I'm facing the single electrons towards barium. Now, easier for me to draw the arrows. Okay, so now when you have all these 3 atoms ready, then you need to show how the electron is transferred. Okay, it will transfer from barium, okay, towards each of the chlorine. So one of the valence electron for barium, make sure you don't put the arrow too close, huh? Okay, so one of the valence electron from barium transfer to chlorine. Another one transfer to another chlorine. So this is the process, not yet product. So you try to draw it first. Okay. So after transferring of the electron, then only we will form product. It looks like a chemical equation, but you show the formation. Okay, so now barium, after losing 2 electrons, it becoming an Ba2 positive. So now we have 2 Cl minus. Okay, so we need to put the number in front. Okay, there will be 2 chlorine, so 2 will be in front of the bracket. Okay, and then over here we have a big bracket, and inside we have a Cl. Okay, so just now chlorine is 7 electron. Now after receiving 1 electron for 1 chlorine atom, it becomes octet. And don't forget your charge for chlorine is Cl minus. Okay, so make sure Ba2 plus and also Cl minus, they are close together. Okay, the forces between them are ionic bond. So later you can practice writing the explanation. Okay, so Ba loses 2 electrons to form Ba2 plus. Okay, and then the electron is transferring to Cl. So Cl atoms receive. Okay, over here because I have 2 chlorine atoms, so maybe you want to put 2 chlorine atoms receiving 1 electron each to form 2F negative. Okay, to form 2 fluoride ion. So that is the required 3 main points. Metal forming cation, non-metal forming anion, and then what is the forces in between? So electrostatic forces between Ba2 plus and also Cl minus. Cl minus kenapa jadi F minus pula? Okay, 2 Cl minus, yeah. So between Cl minus form ionic bond. Okay, so you can refer to the explanation up there. Just changing what is the atom, what is the ion between them. All right, any questions until this part?
No.
Madam,
Yep.
for the barium atom, the Lewis structure, the 2 electrons need to be at the opposite side, right?
Doesn't matter which side. If for barium, right, I can either put it this way, or I can put it opposite side, or I can put it this way, or maybe I want to put it this way. That are all fine as long as they are separate.
Oh, isn't it because of the repulsion, so need to be at the opposite side? No, no such thing.
It is firstly because of Hans rule. Your concept, the repulsions can do, but it's more towards Hans rules. They want to put it singly first to
Alright.
stabilize the atom.
Thank you, madam.
Okay. To make sure everybody can draw the diagrams, the explanation you can refer on the top one. So far, ionic bond is the easiest lah. Okay. So can I proceed to the next one?
Yes, madam.
Okay. So our second bond is covalent bond. Okay, so as you know that covalent bond form between 2 non-metal. So you must know that which one is non-metal. If I say formation between oxygens and nitrogens, okay, both are non-metal, so covalent bond. Okay, so covalent bond form between non-metal and non-metal. It involves sharing of electron. So now, no transferring of electron. Therefore, over here, no arrows. Covalent bonds, no arrows, because sharing of electron, you don't have to show the transferring. Okay, and then the resulted electrostatic forces between the shared electron with the nucleus, it forming covalent bond. So you must mention now what is the bond in between them. Okay, so for examples over here, you look at the Lewis dot symbol. Because both are the same atom, therefore one of it using the dot symbol, another using cross. Tak ada masalah lah kalau nak guna macam ni untuk nampak kan elektron daripada siapa. Okay, so over here you can see the one that Madam bulatkan. Okay, chlorine sharing with another electron, the single electron from another atom of chlorine. So now both of these share together. And you can either write like this, but you need to make sure they are close enough. Or you just represent using one line. Okay, one line, this one is the single bond. In one single bond, there are two electrons in every single Lewis structure. Okay, so one single bond, there are two electrons. So this is your covalent bond. Okay, so when you get a simple covalent bond, it's very straightforward. Just looking the original single atom with the valence electron and then the molecule. Okay, the covalent bond between two atoms. So as the explanation over here, we have each chlorine atom share one electron to achieve the octet configuration or octet rules. Okay, and then the electrostatic forces between the share electron with the nucleus form a covalent bond. So the explanation is much more simple than the ionic bond. So you just mention who is sharing electron and what is the bonds that form in between. Okay, so let's look at the example over here. We have nitrogen. Okay, N2, the nitrogen. So you must remember lah, between the same atom forming covalent bond. So how many valence electron are they?
5.
5. Okay, so I have 5 valence electron. Remember singly first before pairing up. And then madam is looking this way because I'm putting the single electron facing each other. So you can see over here, if I'm using the colors here, one of the electron will pair up over here. Then another one pair up. And then one more, it will pair up. Okay, in your writing, you don't have to color it. You just write as usual and you just show what is the final product. So in this case, I will forming a triple bond between between two nitrogen atoms, and then each of them with one lone pair. Okay, so either you want to write as the bond line. So one line represents two electrons. So over here I have 2, 4, 6. Okay, or you want to write something like this. Dot 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 and another dot 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 over here. Or you want to use the cross also, never mind. Kalau sesiapa yang nak guna cross, make sure you samakan. Reactant awak guna cross, dekat product pun awak guna cross. So for example, those who want to use different sign, okay, it looks something like this. Okay, so that is for the simple covalent bond. That means each of the nitrogen will sharing one electron to form triple bond. So the electrostatic forces between them forming covalent bond. Okay, so any questions up until this part?
So madam, so we can actually represent both of the nitrogens with dots only instead of one dot, another one cross, just like the chlorine example here.
Yeah, you choose yourself. You want to use both using dot, both using cross, or one dot, one cross. So both are accepted. Okay. Right, the next one is the hardest one. So out of these 3 types of chemical bonding, the last one we have dative covalent bond, or we also call it as coordinate bond. Or sometimes it just called as dative bond without the words covalent. But everyone must remember the dative bond or the covalent bond also considered as covalent bond. It's one of the covalent bond. It's just different by the name and the process. Okay, so let's look at the points over here. Yeah, it formed between non-metal and non-metal, exactly like covalent bond. But now, one of the atoms has a lone pair. Okay, so this is important keywords, madam highlight. So one atom has lone pair and they need to donate this pair of electron. Okay, and then I name this species as species A. And then another atom, so Madam highlight juga dekat sini sebab dia atom yang berbeza. Bukan macam tadi, satu atom dia donate satu electron, bukan. Untuk dative covalent bonds, the concept is different. So another atom must contain empty orbitals. So now you're using your knowledge from chapter 2. What it means by empty orbitals. Okay, so I name this another atom as species B. Okay, so it involves transferring of electrons, but this type is not single electron like ionic bond. For dative covalent, we are transferring a pair of electron. Satu elektron ataupun satu pair elektron penting dekat sini dia transfer one pair. Okay, transferring the lone pair from species A, okay, the one that having lone pair, to species B, who having the empty orbitals. Okay, so let's look at the example given here. We have the hydrogen ion, the H plus, and we have NH3, the ammonia species. This is the Lewis structure for ammonia. So Madam will guide you how to draw this Lewis structure in the next topic. Okay, so H positive, H plus, we know that originally H atom has one electrons only. But now H positive, that means totally no electron at all. So in this case, for your H plus, there is the empty 1s orbital. Okay, so this H plus, can it be species A or species B? Is it species A or B, if according to the second and the third point?
B.
B.
Species B, sebab dia ada empty orbital. Tak kisahlah orbital apa, 1s ke, 3p ke, 3d ke. Okay, asalkan dia ada empty orbital. Okay, and then over here for the ammonia, NH3, you can see over here we have a lone pair. So it represents which species, A or B, for NH3?
A.
A. Okay, so for this lone pair on our nitrogen, it will donate into the empty orbital of our H plus. So you will see this arrow over here. Okay, and this arrow indicating this is our dative bond, dative covalent bond or coordinate bond. Okay, so the lone pair from one side only donated to another atom. Compared to covalent bond, just now is both atoms, one donate each. Okay, so is everyone clear about this concept, dative bond and also the simple covalent bond? Ada tak siapa yang confused?
Madam.
Yep.
So the dative bond or the so all the elements, products of the dative bond will be positive one charge.
No. In dative bond, you just need to remember about two of this. Who having lone pair? Species A. Who having empty orbital? Species B. Lone pair from species A will go into empty orbital in species B. Okay, now we'll look at the explanation to make sure you understand about this one. Okay, so you need to explain who is having the empty orbital. Okay, so H plus having empty 1s orbital. There is an empty space for you to accept that lone pair. Mesti kena ada tempat kosong baru kita boleh buat exception kan? Okay, lepas tu untuk nitrogen, dia ada lone pair, baru dia boleh donate. So seorang adalah donor, seorang adalah acceptor. So nitrogen have lone pair electrons. So the lone pair electrons in N are transferred to the empty orbital in H plus. Okay, and this forming our dative covalent bond. So Madam tunjuk lagi satu contoh dalam H3O plus. Okay, so I'm showing the Lewis structure straight away, and then after that, I will guide you how to draw the Lewis structure for NH3, for H2O, and so on. Okay, so H3O, it means we are coming from H2O plus H plus into H3O plus. This one is a simple chemical equation without showing the structure. Tapi kalau awak nak tunjukkan formation, show the formation bukan formative. Kalau awak nak tunjukkan formation, mesti kena structure penuh. Mesti kena tunjukkan Lewis structure. So dekat sini Madam hanya tunjukkan Lewis structure, nanti Madam akan ajar. Okay. So now tell me, I just want you to understand. Tell me which one is species A, the one having lone pair. Is it H2O or H positive?
H2O.
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 Dia ada dua pair kan? Dua lone pair. So species A is your H2O. How about H positive?
Yeah.
Species B. Okay, so electrons moving from where to where? Transfer from where to where? From A to
B.
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 Okay, so the lone pair over here, maybe using another color. No color. Okay, this one you don't have to show, just to let you know where is it transferring. So it's transferring from A to B, from the lone pair. But when you want to write your answer, you have to write it. You have to show the electrons, you show the arrows inside your product. So the overall charge over here, we have a positive. And then after that, show which one is your dative bond. So dative bond, every time you must label. Okay, so the structure for H3O plus, showing the dative bond, it looks like this. So make sure you check out where is the arrow, from where to where, from oxygens to hydrogen. Okay. So let's just try some exercises, yeah? Okay. Dekat sini Madam akan tunjuk satu contoh untuk satu part saja, yang lain awak try sendiri ya. Okay. So for formations of ionic compound, I think most of you are okay. So for three of these, Madam just give you some guideline. Okay, and then you just complete it. So magnesium, there's 2 valence electron, bromine, that's 7. So exactly the same like just now. Aluminium oxide, there's 2 aluminium. And then how is it transferring the electron to oxygen? Okay, so fill in the blank for your explanation. Okay, I want to show you question number 2. Show the formations of bond in H2S. So what bond inside H2S? Is it ionic, covalent, or dative? So one clue over here, helium and also hydrogen, we are consider them as the non-metal. Even though hydrogen is group 1, but it doesn't have the ability to attract electron or losing electron or transferring electrons. Okay, it doesn't have the ability to transfer electron like the normal metal, like lithium or sodium. So we will classify the hydrogen as non-metal. So let's say over here H2S. So what bond exists in this compound? Catatkan hydrogen kita jadikan dia sebagai non-metal. So what bond? What is the bond that exists inside H2S?
Covalent.
Covalent. Yang lain faham ke?
Tengah cuba memahamkan.
Faham.
Cuba tak faham kan Okay. So hydrogen non-metal, sulfur non-metal. So both of this we will having the covalent bond. Sebab dia bukan H+, sulfur pun tak ada tak ada lone pair. So dia bukan dative lah. Okay, yang ini adalah simple covalent bond. Okay, so over here hydrogen we have 1 valence electron. Okay, remember sharing of electron, we want to share to make a bond. So Madam will do it this way. H2 has. Sebab dia bukan transfer electron. Kita tak boleh susun dia macam ionic bond. We cannot arrange it that way. So, for sulfur, there will be 6 electrons. So I will arrange it this way. 1, 2, 3, 4, 5, and 6. So I'm making sure the single electrons facing towards the hydrogen. So over here, I can make one single bond. Okay. And then another side for sulfur, I can make another single bond. So in this case, after you combine both of them together, okay, so it becomes H, S with another 2 lone pair, and then another hydrogen, just showing the sharing of electron between sulfur and also hydrogen atoms. Okay, so
Nak tanya lah.
apa dia?
Nak tanya, kenapa yang tadi dative bond tu, dia mesti ada arrow
Ya, dia nak tunjuk dari mana ke mana. Untuk setakat ni awak nak cuba fahamkan dia punya elektron dari mana ke mana.
Okay, faham.
Nanti boleh apply juga, nanti ada ajar macam mana nak lukis Lewis structure. Nanti boleh apply juga untuk H3O+. Cuma setakat ni awak kena faham lah dative bond dia form macam mana. Okay. So Madam try one examples for the dative, yeah? Dative bond covalent for BF3 and H3. So I give it the structure BF3. Your copy, yeah? Okay, this structure Madam will give you. So NH3 is like just now. Okay, don't pen. Okay, so in this case, you need to identify where is the lone pair, which one is species A. Where is the empty orbital, then where is the species B. Okay, so anyone will tell me which one is species A with the lone pair? Well, we are focusing on the central atom, central atom.
NH3 pergi ke BF3 ke?
NH3 ada lone pair kan? Ni example tadi kan? Okay, so here is your lone pair. So that means NH3 is your species A. Okay, which one is your species B and why?
BF3, maybe because it doesn't have lone pair.
It doesn't have a lone pair but it have anti-orbital. Kenapa ada empty? Madam nak tanya, kalau untuk satu atom, maksimum kita boleh dapat 8 valence electron. Okay, octet kan? Cuba tengok dekat boron. Ada berapa elektron saja dekat boron?
Ada 6.
6. 2, 4, 6. Satu line 2 elektron. So dekat sini 3 line. So 6 elektron saja. Kemana hilangnya 2? So memang dia punya structure macam ni. So memang Madam bagi structure lah. There is exception. Okay, there is exception rules for boron. So now you need to make sure to identify boron having empty orbital. Sebab dia belum sampai lagi 8. Sebab tu dia ada empty orbital. Okay, so let's just fill in the blank. Boron has an empty, empty orbital. You want to see from which subshell, you can check it from the electronic configurations. So boron, how many, what is the proton number?
5.
Okay, proton 5. So we have one S2, 2 S2, and
3 A2P1 A2P2 2P1.
Apa dia Irfan? So empty orbital dekat sini adalah
5.
which orbital? 2s, 2p.
2P.
2p orbitals. So after it's sharing with 3 fluorine, so now you have an extra 2p empty orbital. Okay, so you just want to check. You don't have to see which how they pair up. So in Lewis structure, you will learn that. You just need to identify which one is the empty orbital. So in this case, the last electron is 2p. So your possible empty orbital, it fall into 2p subshell. Okay, and then in this case, the nitrogen has the lone pair electrons. So the lone pair electrons in NH3 are transferred into empty orbitals in BF3. Okay, or you want to make sure you write the complete sentence, you can say the lone pair in nitrogens of NH3 transfer to the empty orbital in boron of BF3. Okay, to form this dative covalent bond, dative bond or coordinate bond.
Sure.
Okay, so madam show you the final structures. So F, B, F. So the rest of it you continue. The lone pair of fluorine continue. So over here you will see the lone pair from nitrogens donate to the empty orbitals in boron. And then the rest of the hydrogens we just continue. We just copy it back only. And then this one is our dative bond. Okay, so Irfan nak tanya soalan ya?
Kita tahu kat situ boron ada 3 line kan, tiga line maksudnya ada 6 elektron kan. Tapi kita tahu boron punya electronic configuration ada 5 elektron. 5 proton. Proton 5 elektron. Kenapa dia ada 3 line? Bukan patutnya dia 5 elektron ke? Maksudnya ada, macam mana nak cakap? Bukan patutnya ada ni ke apa? Lone pair.
Okay. Irfan tengok valence electron untuk boron berapa ya?
3.
Proton number ya dia 5. Tapi dekat sini valence electron dia hanya 3. So satu share dengan satu fluorine. Satu share dengan fluorine yang kedua. Satu share dengan fluorine yang ketiga. So dah cukup dah. Sebab dia hanya 3 valence electron saja. Ya, jangan termasuk 1s sebab 1s bukan valence electron. Okay. Boleh ya?
Faham.
Alright. Madam tanya untuk proton number confuse kan awak ya. So madam padamkan yang inilah ya. Jangan confuse kan. Asalkan awak ingat valence electron. Sebab nak tunjukkan dia punya covalent bond dalam BF3 sharing electron kan. Kita hanya tengok valence electron dia sahaja. Okay. Yang ni sebab madam nak tunjuk orbital dia kat mana. Empty orbital dia mana satu. Kalau H plus kita tahu empty orbital dia 1s. Tapi untuk boron nak tengok empty orbital kat mana, terpaksalah madam rujuk sikit dekat electronic configuration. Okay, so the next part over here, Al2Cl6, madam give you the starting structure. And then I want everyone to try drawing the arrow from where to where. So madam bagi dulu structure Al2Cl6. Okay, you can copy down and then you can try an arrow. So this is one of the AlCl3. Okay, and then we have another structures of AlCl3. Memang madam dah siap-siap bagi dia punya direction. Cuma nak awak masukkan dia punya arrow sahaja. Fikirkan dekat sini hanya chlorine dengan aluminium saja. Siapa yang ada lone pair, siapa yang ada empty orbital. Okay, so there will be a final structures. And madam will discuss this one in our next class. Okay, remember to identify species A, species B. Okay. So for this one, Madam will give you the answer to check for the next sessions lah. Okay, come to the next difficult part is about the Lewis
Madam,
structure. Yes.
can you show the structure for the ALCL one more time?
Okay, sorry.
Right, hold on. All right. Thank you.
Okay. So next part, we do it together, Lewis structures. Lewis structures very, very important. It will determine your 4.2 and 4.3 and also 4.4. So if you cannot get the idea of Lewis structures, the rest of the chapter tak payah harap boleh buat jangan harap boleh buat So memang kena pastikan semua orang tahu macam mana nak lukis Lewis structures. Dengar betul. Okay, so there is the step in guiding you how to draw the Lewis structures. So let's look at overview for the step. Step 1, count the total number of valence electron. If you having the formula which have the negative overall charge, you need to add electron. Positive charge, subtract electron. That is step 1. Step 2, you need to draw the skeletal structures. Okay, and then put the least electronegative atom as the center. So beside hydrogen and helium, always at the side because they can only form duplet. Okay, so the least electronegative negative atom will be in the center. When we're talking about the least electronegative, back to your chapter 3, we got FON. If you still remember, madam, when explaining about electronegativity, we talk about this one. Fluorine is our champion. Okay, it's the most electronegative. Then oxygen will go to the second place, nitrogen's the third place. Then if you look at group 17, down below fluorine, we have fluorine. So this one will be the fourth place. And then continue last sulfur and phosphorus on the same period. So you remember the four places, the four first places to compare. Okay, and then using your knowledge across the period, what will be its atomic size, then what will be its ability to attract electron to determine who is the most electronegative atom or the least electronegative atom. And then after that, our step 3, count the number of electrons which is used to form covalent bond and subtract from the total number of electrons. Number 4, complete octet for all atoms except H and E. Surrounding atom must be octet first. Okay, before placing the remaining electron at the center. Okay, electrons not involving in bonding. That means over here, if you got extra electron after all the step above, okay, then the extra electron we will put on the center. Step number 5, if you need it, then we only proceed to step number 5. So if center atom is not yet octet, okay, except for BE, B, and also AL, make multiple bond by using lone pair from the surrounding atom. So this one, madam, will guide you how to do it. And step number 6, count the formal charge. Also got this formula to calculate it. So let's just start with H2O. Tadi madam cakap nak tunjukkan macam mana nak dapatkan H2O yang madam lukis tadi itu. Okay. So hydrogen, we have the valence electrons of 1, but because there is H2, so 2 times 1, we have we have 2 valence electron. Okay, oxygens from your group 16, there is 6 valence electron. Okay, so in total over here we have 8 valence electron. Everyone get it? That is your step number 1. Adeka?
Yes.
Okay, so step number 2, draw the skeletal structure. So placing the least electronegative in the center. So since we know hydrogens were always in the terminal, okay, always at the surrounding, then no choice, we have to put oxygen in the middle. Okay, so in this case, I have, you want to put it like this, you want to put it sideways, doesn't matter. So let's say madam put it this way, hydrogen. So this one is my skeletal structure with the oxygen at the center. Okay, so step number 3, count the number of electrons which is used to form covalent bond. Okay, so now in here we have 2 and 4. So minus 4 valence electron, how many left? 4 more remaining. Okay, so remember, one line over here represents 2 electrons. So hydrogen, oxygen, 2 electrons.
Madam,
Yes?
why do we subtract 4 valence electron just now?
Okay, because over here we got 2 electrons. A single bond having 2 electrons. Over here, 2 electrons. Over here, 2 electrons. That's why we subtract 4 electrons. So over here, count the number of electrons used to form covalent bond. Subtract from the total number. Okay? And then this one is the remaining. Okay, remaining you have 4 electrons. So let's look at step 4. Complete the octet, but except for hydrogen. So over here, hydrogens have already achieved duplet. Okay, so you cannot make hydrogen octet. So hydrogen tinggal macam ni sajalah sebab dia sudah ada 2 elektron. So the surrounding atom is already duplet for hydrogen. Then the remaining electron will place at the center as lone pair. So madam nak tahu satu lone pair ada berapa elektron? 2. Sekarang ada 4 elektron lagi. So ada berapa lone pair?
2.
2. So dekat sini 4 valence electron remains. That means you have 2 lone pair. So lone pair, we put it on the oxygens. 1 pair and 2 pair. So make sure the lone pair you put it separately. Jangan buat macam ni Kalau let's say awak nak buat macam ni boleh. Dia masih sama, cuma dia punya single bond, madam letak tempat lain. Tapi dia masih dekat center yang sama, so tak ada masalah. So let's say saya ada 2 lone pair kan, satu atas, satu bawah. Okay, you cannot do it this way Jangan buat macam ni, ada 4 elektron terus letak macam ni. Cannot. So this one is wrong. Lone pair separate kan. Satu pair letak satu tempat, satu pair letak dekat tempat lain. Make sure pair you always stick it together. Okay, boleh?
Boleh.
Okay, kita cuba Cuba yang lain. Madam badangkan yang dekat sini dulu. Untuk CCl4, who is the least electronegative? Kita start dengan Lewis structure, dengan valence electron dulu. Cuba kira kan? Chlorine, how many valence electron? Kalau carbon? Carbon, how many valence electron?
2.
Carbon 2.
2.
4.
Carbon 14, 4 valence electron. Chlorine, 7 valence electron. Tapi dekat sini awak ada 4. 4 darab dengan 7 dapat berapa?
28.
28. There is no charge, so we don't have to add or subtract electrons. So overall, 4 plus 28, you got 32 valence electron. Okay. So siapa duduk tengah? Step 2, who is sitting in the middle? Cl or C?
C.
Carbon. Okay, so I make my skeletal structure. Carbon in the middle because carbon is less electronegative. Okay, so this is our step number 3. So over here, 2, 4, 6, 8. So we have got 8 electrons already. So minus 8 valence electron. How many left?
24.
Berapa lagi tinggal
24.
24.
24.
Okay, so minus 8 valence electron. We got left another 24. Agree?
Agree.
Okay, so step number 4, complete the octet for all electrons surrounding atoms must be octet first. So now for your chlorine, I put my my octet electrons first. So for chlorine, another 3 lone pair. So 2, 4, 6, including the single bond, you got 8 electrons here. Okay, another 2, 4, 6 for the second electrons. I have 8 already. 2, 4, 6, 8. 1 line 2 electrons, so including already. So complete for all surrounding chlorine atom. So now calculate for me 6 electrons for each chlorine. 6 times 4, how many?
24.
24.
24.
Any remains?
No, madam.
That's it. So no remaining electrons, so you don't have to put anything on the carbon. So we stop until step 4, no step 5 also. Okay, try one more example for NH3. Nitrogen, how many valence electron? Nitrogen, how many valence electron, Irfan?
Yep, saya tak ingat.
Tak ingat, tadi dah mention banyak kali
7.
dah. 7, Azim?
Salah.
Five. 5.
Hai,
5.
nitrogen group 15, 5 valence electron. Hydrogen, 1 valence electron, but because there is 3, so 3 valence electron. Okay, altogether?
8.
8 valence electron. Very good.
8.
Okay, so we put our skeletal structures. Who will be in the middle?
Nitrogen.
Reason?
Because it have 5 electrovalence. No.
No.
Any ada S? tolong.
It is less
Yes,
positive.
electronegative, not positive. Like, bulatkan yang ini.
Negative.
The least electronegative sitting in its center. Okay, so now we have nitrogen in the middle, hydrogen at the surrounding. Okay, surrounding hydrogen duplet, fully duplets already. So now we have 2, 4, 6 for the covalent bond. Here 2, here 4, here 6. 8 up together lah, 3 lines, that means 6 electron. So we minus 6 electron. How many left?
2.
2. If you got remaining, where should I put?
At the nitrogen.
Lone pair.
On the nitrogen. That's why nitrogen having lone pair. Is that okay? Part ni memang susah lah. Memang satu cabaran besar kalau nak ajar online. Kalau dalam kelas memang satu-satu tangan ketuk. Siapa yang salah ketuk. Ketuk otak. Okay. So, just now we take the example H3O to show the dative bond, but we can also show the structure of H3O using the concept in Lewis structure. Okay, so let's just see this one. Now we back to the table, yeah? H3O, hydrogen, 1 valence electron. Oxygen, 3 hydrogen. So dekat sini ada 3 valence electron. Okay, 3 hydrogen. That means 3 valence electron. Oxygen ada berapa? 6. 6. So overall charge over here, H3O, positive. So the positive charge, that means you need to add electron or subtract.
Subtract.
Subtract how many?
1. So
1.
-1.
Okay. So 9 minus 1, now you got 8 valence electron. So similar like oxygen, but now we have 3 hydrogen. So this is your skeletal structure. Okay, kalau awak tak suka buat macam ni, madam, boleh tak saya buat macam ni? Tak ada masalah. Sebab dia masih sama, central adalah oksigen. Tak kisah awak pusing macam mana pun. Okay, so now our third step. Count the number. So surrounding hydrogen duplet. So we have done. The middle one, the 3 single bond, here we have 6 valence electron. Similar like our NH3, how many left? 2 kan? So yang remaining electron letak kat mana?
At the oxygen.
At the oxygen. So that means H3O plus, there is 1 valence electron. So overall charge positive. So you're using a big bracket and then put your positive charge outside the bracket. Memang kena banyak practice untuk Lewis structure. So kita nak tengok madam nak ajar untuk step yang kelima macam mana kita apply pula. Step number 5 says that if a central atom is not yet octet, because we want to make sure every single atoms they can at least achieve octet. Beside the exception sebab dia ada exception juga. Ada anomalous juga exception. Okay, so let's look at our CO32 minus. So using your concept, carbon, we have 4 valence electron. Oxygen, there is 3 oxygen. So altogether, how many valence electron? 3 times 6.
18.
18.
18.
Negative 2, how many you need to add on?
Plus 2.
Plus 2. Altogether?
24.
24 valence electron. So who is in the middle, oxygen or carbon?
Carbon.
Carbon. Ingat oksigen tempat kedua. Kalau kita compare FONCl, oksigen tempat kedua. So maksudnya carbon dia tak ada tempat langsung. So carbon in the middle. So I have oxygen at the surrounding. Okay. So now I have 3 single bonds over here. That means I need to subtract 6 valence electron. How many left? 18. Okay. Lepas tu check step yang keempat Completekan surrounding atoms with octet. So oxygen, I got 2, 4, 6. 6 times 3, you got 18. Ingat, dekat sini madam buat step yang keempat penuhkan surrounding atom dengan octet. So maksudnya untuk satu oksigen, madam masukkan 6 elektron. Okay, 6 elektron. Dekat satu oksigen tengok 6 dot tu. So 6 electron, 3 oxygens, there is 18 valence electron we use. So now nothing left. Semua kita nak guna untuk octet surrounding atom. So now nothing left. But my carbon is not yet octet. If you look at the carbon, it still only got 6 electron. So it's not enough. So step 5, we need to borrow the lone pair from surrounding atoms to make multiple bond. Okay, make multiple bond by using lone pair from surrounding atom. Multiple bond dekat sini maksudnya kalau ada double bond ke triple bond. Okay, so macam mana nak bincang madam padamkan salah satu lone pair. Nampak kan madam padam? Can you see I deleting one of the lone pair?
Yes.
Yes, we saw it.
Okay, so this lone pair, 2 elektron kita buat dia sebagai double bond. So sekarang hanya guna 2 elektron, satu lone pair, kita share antara oksigen dengan carbon. So this is your step 5. If center carbon is not octet, then we use surrounding lone pair. Okay, so kalau ada contoh, madam boleh tak saya tak nak guna oksigen yang pertama? Boleh je, tak ada masalah. Let's say I want to use the second oxygen. So let's say I removing one of the lone pair from my second oxygen. Okay, so using the lone pair, making your double bond. So now oxygens are all octet. 2, 4, 6, 8, 2, 4, 6. Every oxygen is octet. Carbon also octet. 2, 4, 6, 8. Remember, 1 line, 2 electron. So now this is your structure for CO3 2 minus. Any questions?
Madam, so we can actually choose any of the oxygens, right?
Yeah.
Alright.
Okay, so try CO2. Tak ada 2 negative. So carbon, 4 valence electron. Oxygen, there is 2, so that means 2 times 6, we got 12. 16 valence electron. Carbon in the middle. Skeletal structures, oxygen in the surrounding. So now in the middle, with 2 single bond, I have 4 electrons. So 2 from each single bond. So over here, I have 4 electrons subtracted. So left with 12 valence electron. So step number 4, complete your surrounding atom with octet. So oxygen, oxygen, oxygens. So 6 electron I'm adding, but 2 oxygen. So there is 12 valence electron. No remaining, but my carbon is not yet octet. So now I have to do something. I have to rub off my one of the bukan rub off borrow one of the lone pair to make one double bond. Okay, oksigen yang ini dah octet. Oksigen yang sebelah kanan pun octet, tapi carbon belum lagi. So pinjam sampai carbon jadi octet. So you have another choices over here. So let's say madam want to borrow the lone pair from another oxygen. So I rub off again my lone pair. Okay, and then I make a double bond. So oksigen pertama octet, oksigen kedua octet. Okay, center carbon pun octet juga. Sebab dia ada 4 line. 4 line 2 elektron, 8 elektron dah octet. Is everyone okay? Madam harap boleh ikut sebab part ini sangat-sangat penting. Kalau Lewis structure salah, semua subtopik yang berikut akan salah juga. Okay, so make sure you practice this one ya. There is another option as well. So let's say tadi madam stop kat sini kan, satu double bond carbon, satu single bond carbon. Yang tadilah. So let's say dekat sini. Okay. Another way is say, madam, can I use the same the lone pair from the same oxygen? Can, no problem. I wrote off one of the lone pair from the first oxygen just now. I take the lone pair, right? So I take another lone pair. I'm making one more bonding. So now we have the first bond is triple bond. Okay, try to check the overall electron is still 16 or not. Nah, tadi 16 kan yang overall dekat sini. Check dekat structure ini, ada tak saya punya elektron masih 16 lagi?
Yeah. Yes.
Is my oxygen octet?
Yes. Yes.
Is my carbon octet?
Yes.
Yes. So, maksudnya dua-dua structure ni boleh diterima. Okay? Formal charge nanti dekat subtopik sini madam akan ajar ya. So dekat sini madam masukkan dekat table saja. Okay. Last one, N2. Tadi kita pun guna dalam tunjukkan covalent bond kan, nitrogen. But now using Lewis structures theory also we can use. So nitrogens, there is 2 nitrogens. That means 2 times 5, we have 10 valence electron. But in this case, we have no center atom. Sebab 2 atom saja, tak ada siapa yang center. Okay, so nitrogen, nitrogen. And there's only 1 single bond, so 2 electrons. So left with another 8 valence electron. So let's say I want to complete, okay, the octet for both nitrogen. So hanya ada 8 kita agikan evenly Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay. Dua-dua nitrogen belum octet. Tapi saya sudah tak ada valence electron lagi. Cuba kira balik 2, 4, 6, 8, 10. Total electron dah habis guna. It's already completely used, your valence electron. In this case, we proceed to step number 5. Borrow one of the lone pair, making a multiple bond. Madam, nitrogen yang pertama belum octet. Tak ada masalah. Saya pinjam sebelah. Buatkan lagi satu multiple bond. So in this case, the number of electrons is still the same. 2, 4, 6, 8, 10. But both nitrogens happily ever after. Dah octet lah. So boleh gunalah konsep untuk Lewis structure untuk semua covalent species. Okay. So, Madam let you complete first. Dan Madam nak awak highlightkan ini juga. Covalent molecule saja yang kita pakai Lewis structure Untuk ionic macam tadilah. Untuk metallic dia ada benda lain. Yang ini hanya untuk covalent molecule sahaja. Alright. So, any questions until this part? Jangan skip step Step 1, 2, 3, 4, 5 semua kena ikut. Okay, so any questions before Madam proceed?
No, madam.
Yeah. Okay. So, the next part we want to talk about is the exception rules. Including yang tadilah kenapa boron dia hanya 6 elektron sahaja. Okay, let's look at this one. Okay, first of all, bond length. Yang ini simple sajalah. Madam just highlight it first. Bond length is defined as the distance between two atoms. Okay, between a nuclei from two covalently bonded atoms in a molecule. So like just now, nitrogen and nitrogen, chlorine and chlorine. So this is the bond length. Then the length, single bond is the longest, followed by double bond, followed by triple bond. Okay, and this is because the strength. If you're looking at the bond, let's say Madam using a symbol X. Let's say single bond XX is longer than double bond. Is much more longer than our triple bond. Sebab bond kalau dia lagi banyak triple bond, sebenarnya dia punya forces of attraction is stronger. So we can see the strength for triple bond is the strongest. So strongest bond giving you the shortest length. Weakest bond give you the longest length. So kaitkan awak punya bond length dengan dia punya strength. Triple bond is the strongest, therefore shortest. Single bonds is the weakest, therefore the length is the longest. Okay. Then we come into exception octet rules. There is 3 rules that you need to remember. Incomplete octet, expanded octet, and also odd number or odd electron octet. So first one, incomplete octet, occurs when your center atom has less than 8 electrons. So this occurs when you have element from group 2 and group 3 in period 2, which is your Be, your beryllium, boron, aluminium. We call it as bubble, Okay, Be, B, Al. So these 3 elements, even though they are metal, okay, even though they are metal, but because of their low metallic property. Sebab kalau awak imagine, period tu dia kecil sangat. Nak dia keluarkan elektron susah sebab force of attraction is very strong. Okay, so beryllium, boron, aluminium, less likely to donate electron due to this strong forces of attraction. Okay, therefore, awak kena ingat Be, B dengan Al, mereka hanya wujud covalent bond. Tak ada ionic bond. Except for aluminium fluoride. So dekat sini Madam ada bagi alert, suruh awak ingat alert. Kalau ada bebal memang incomplete. So BeH2 for example, BeCl2, BeF2, so this is the example. Okay, BF3, BH3, BCl3, they are all covalent. They are all incomplete. AlCl3, AlBr3, AlI3, they are all covalent and they are incomplete. Okay, incomplete octet. But when you come into AlF3, okay, because fluorine it has the highest electronegativity. Sebab kalau aluminium pair dengan fluorine, dia akan jadi ionic. Tapi hanya ini sajalah, lain tak ada. Okay, untuk aluminium dengan chlorine, aluminium dengan bromine, aluminium dengan iodine, semua akan jadi covalent. So make sure you understand, you jot down the table over here. So this is the examples given. Madam bagi extra examples lah. You can jot down BeCl2 and etc. Okay, only Al-F3, aluminium trichloride, is an exception. The rest of it, as long as you see beryllium, boron, aluminium, they are all incomplete and covalent. Okay, so beryllium, hydrogen and BH2, only 4 electron in beryllium, less than 8, therefore it is incomplete. So macam tadi BF3 sebab boron 6 elektron saja, kurang daripada 8. Okay, it is incomplete octet. So any question for the incomplete octet? Yes, class? Tak ada ya? Okay. And then we have expanded octet for the second one. Occur where center atom has more than 8 valence electron. And then it usually involves no metal from period 3 and onwards. Period 3, period 4, period 5, because they have D subshell. Now, if it's from period 3, then 3D subshell. Period 4, then 4D subshell. Okay. And then this is important because when you have D orbital, you can put in more electron. That's why it can expand. So ini adalah dia punya reason setiap kali kalau soalan minta ataupun dia tanya, okay, it usually include the reason of the empty D subshell, empty D orbital. Guna subshell ataupun orbital pun boleh. So example using SF5, SS6. So sulfur, why sulfur can more than 8 electron? 2, 4, 6, 8, 10, 12. There's 12 electron in sulfur. Okay, obviously it's more than 8 electron. Therefore, it obey the expanded octet. So the reason, because sulfur is come from period 3, it has empty 3D orbitals. Okay, last one, electron octet is less common. It's less common only for group 17 and group 15 only. They're very rare. You can see this example. So electron octet is when your central atom contains an unpaired electron. That means only one single electrons in the structures. Okay, so most odd electron molecule has the center atom from odd number group, usually group 15, nitrogen, group 17, chlorine. So as you can see the example over here, nitrogen NO, okay, nitrogen having the single unpaired electron. So only 3 electrons in nitrogen, so odd number electrons. Okay, so there is the 3 exceptions octet rule: incomplete, expanded, and odd electron. So every time when you practice for your Lewis structure, you can mention what is the octet rules. Is it common octet rule? Then you don't have to label. If it's incomplete, then label incomplete. Expanded, label expanded. Okay, so this exercise, I want everyone to try and do all of them, A until J, and then submit it to Google Classroom. You can use the template given. Mereka ada attach template dalam Google Classroom. So you can submit, you can draw it inside this template. Okay, so ada apa-apa soalan untuk Lewis structure? Kan Medan tunjuk lagi?
Ada.
So for the expanded octet, so for the expanded octet, it's only applied on the transition elements, right?
Yes. P orbital also, P group also can. It doesn't depends on the block. Just now also very clear already. This one. Expanded octet, it depends on period. As long as you are period 3 and above. Kalau dia period 3 tapi dia group 17, still can do the expansion. Okay, so it depends on period and then bukan depends on the block. Okay, so using the ways step 1 until step 5 to complete the table here.
Madam, so
Yes.
Do we need to show the calculations for the
Yes. Yes. Tunjuk macam tadi Madam buat lah. Madam buat sekali kan. Okay, show the calculation. as well as your Lewis structure.
And then about the length of the bond, we need to like very careful about that
No need.
drawing.
No. You don't have to show the exact length. This one is just knowledge for you to compare between their length. But in your Lewis structure, you don't have to show the length.
Okay.
Just do it usually. Okay. Okay. Next one, madam want to show you the formal charge. So for this one also, you can practice in the template just now. So madam show you 3 more Lewis structures. So formal charge also depends on your Lewis structure. And let's look at the point. Must draw as Lewis structure. Apply the formulas to calculate formal charge for all atoms in the molecule. Bukan satu atom saja, untuk semua atom. Kalau structure itu ada 5 atom, so calculate untuk semua. Okay, so here are 2 formula. You can use either one of them, but madam will choose to use the second one. Formal charge equal to number of valence electron minus the number of lone pair electrons and the bonding pair. So let's look at SF4. Okay, sulfur, we have 6 valence electron. Fluorine, we have 4 fluorine, so altogether 28. Okay, so over here we have 34 valence electron. So sulfur is the least electronegative compared to fluorine, so it's sitting in the middle, surrounded by 4 other fluorine atoms. Okay, so 2, 4, 6, 8 minus 8 valence electron, you're left with another 26. Ada madam terlalu cepat ke, boleh ikut tak? Boleh. Okay,
Boleh.
so after minus the covalent bond, okay, we're left with another 26 valence electron. So step number 4, complete the octet for all the surrounding atoms. 2, 4, 6, and then you have 4 fluorine atom. So 6 times 4, we got 24. So now 2 valence electron left. That means you have 1 lone pair at the center. Okay, so on my sulfur, there is 1 lone pair. So make sure the lone pair always stick together. So make sure they are side by side. The lone pair.
Madam, so the lone pair can be situated in any angles between the covalent bond. Am I right?
Yes, you can put it here, you can put it here, you can put it here, as long as they are together.
All right.
Okay. Right. So can anyone tell me for SF4, which exception rules does it obey? Incomplete, expanded, or odd electron? Expanded. Because sulfur from period 3, it has empty 3D subshell. Therefore, it can expand. Okay, so now we back to our topic, yeah? Calculate for the formal charge. So, madam nak awak kirakan, madam guna warna biru. Okay, so let's just look at sulfur first. Okay, sulfur valence electron, we got 6 valence electron. Okay, madam is looking at this formula, yeah? And number of lone pair electrons, over sulfur, we have 2 lone pair electron. Maksudnya satu dot kira satu. Sebab dia minta lone pair electron. So on our sulfur, there is 2 dot. That means 2 electrons. Okay, and kita nak tulis yang ini pun boleh terus number. Okay, 6 minus 2. Another one, if I open in the bracket, that means minus the lone pair electron minus the bonding pair. Okay, bonding pair in this case means 1 line, 1 pair. Kan satu single bond kita ada 2 elektron kan. Kalau saya cakap bonding pair, maksudnya 1 line, 1 pair. So sulfur ada berapa line? Ada berapa single bond?
4.
4 single bond, that means 4 pair. So dekat sini tolak 4. 4 line, 4 pair. 2 dots, 2 electrons. So yang ni simple saja. 1 line kira 1. 1 dot kira 1. So dekat sini formal charge untuk sulfur adalah kosong. So when this calculation you don't have to show. Once you are expert, you don't have to show. You calculate saja, lepas tu awak terus tulis atas sulfur. Sulfur has a 0 formal charge. Okay, tolong kirakan untuk fluorine sekali saja sebab semua fluorine adalah sama. Fluorine valence electron adalah, cakap sampai twist tongue dah. Twisted tongue. Fluorine valence electron berapa?
7.
Ada berapa lone pair electrons untuk satu fluorine? Berapa dot? Berapa dot?
6.
6.
6 dot, right? Each fluorine has 6 dot. So 7 minus 6. How many line do fluorine have?
1.
One line, one pair, tolak 1. So 7 tolak 7, kosong. So semua fluorine adalah kosong. Ini adalah formal charge.
Madam, can you explain one more time about sulfur?
Okay, so focus on sulfur, ya, Hazim. So valence electron for sulfur, there is 6. Okay, madam using a highlighter, yeah. So valence electron 6. So where is this value of 2 come from? You look at sulfur, there is 2 dot. So maksudnya kalau Lewis structure awak salah, formal charge pun akan ikut salah juga. Betapa penting lah Lewis structure dia. Okay, so 2 dots meaning you have 2 lone pair electrons. Okay, so 2 dot value is 2. And then for 4, if you focus on sulfur, there is 1, 2, 3, 4. 4 lines in it. So bonding pair also 4 pair. So dekat sini 4. So main kira sajalah 6 tolak 2 tolak 4 dapat kosong.
So 0 means neutral. So if it's 1 means it's positive 1 charge.
Yes. If it's negative 1, then you run on top negative.
And vice versa.
Yes. Show you another example. Let's say we have Cn minus. Carbon 4 valence electron. Nitrogen, we have 5 valence electron, negative charge. Nak tambah ke tolak?
Tambah.
Tambah. Okay, so sekarang kita ada 10 valence electron. No central because only 2 atoms. Okay, so Cn, in the middle we have 2 electrons, so we left with another 8 valence electron, tak cukup tempat. Kalau awak sudah hebat step 1 hingga 5, nanti madam ajar shortcut lagi. Tapi shortcut tu mesti kena awak mesti kena tahu step dia dulu. Okay, so 10 minus 2, remaining 8 valence electron. So similar like our N2 just now, we complete the surrounding with the electrons. So 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Finish. No more electrons. But the carbon and nitrogens are not yet octet. Therefore, you have to do something to make a multiple bond. Okay, borrow one of the lone pair from carbon to make the double bond. Borrow another lone pair from nitrogens to make a triple bond. So now if you're checking at the Lewis structures, you can see carbon, octet, 8 electron, nitrogen also octet. Don't forget the overall charge is negative. So now calculate for carbon. What is the formal charge for carbon? Valence electron carbon?
4.
4. How many lone pair electrons? How many dot on carbon?
2.
2. How many lines on carbon?
3.
3. So what is the value? 4 minus 5?
Negative 1.
Okay, so formal charge for carbon is negative 1, right on top of carbon. And then for nitrogens, valence electrons is 5. How many dot on nitrogen?
2.
How many lines on nitrogen?
3.
What is the value?
0.
0. So nitrogen having a 0 formal charge. Okay, so H3O plus, the structure just now, Madam had already guided you how to do. This is your overall charge for, sorry, this is your structures for H3O plus. Can you try to calculate for oxygen's formal charge and also for hydrogen? For oxygen, 6 minus
2.
6 minus 2 minus
3.
3. 2.2, 3 line 3. So dekat sini oxygen's having a positive 1 value. How about hydrogen? Valence electron 1. There is no lone pair electron, but hydrogen having one line, so 1 minus 1, 0. So all of the hydrogen, you are having a formal charge of 0, and the oxygen's having a formal charge of the positive 1. Okay, so everyone's clear, yeah? This part, it depends on your Lewis structure. So everyone, please really practice on the Lewis structure. Okay, otherwise you will mix up a lot of things. Nak catch up pun susah juga Right. So any question you would like to ask about the formal charge or Lewis structure? You takutnya Madam nak proceed.
Madam,
Yeah.
when do we need to perform the calculation for formal charge?
Formal charge, the calculation step you don't have to write unless the question say it's a written exam. Like if the question say show the calculation for each formal charge, then only you showing. Otherwise, you just punching your calculator and then you write the bracket thing.
So every time we draw the Lewis structure, we need to do the calculation for the formal charge.
Safer plan lah. Safer plan you calculate for everything because sometimes we will need to use this formal charge, which is our next topic here. Now, why is the formal charge important? It depends on our next topic. So we cannot say every time you have to calculate, but it will be safer lah. If let's say you say SF4, the first example, the formal charge is all 0, so it is not necessary for you to calculate, but it just to double confirm. Okay, there's no formal charge, and sometimes it will need. So there's not a necessary say which questions need to calculate, which you don't have. So you can just punch in the calculator. If let's say everything is 0, then you don't have to write. If there is one atom carry a non-zero value, then you write out.
So the formal charge, it serves for some specific purposes lah. Sometimes it is meaningless lah. Sometimes
Yes,
it is
sometimes it's meaningless. Yes, exactly. Sometimes meaningless, but sometimes we need to use that one. So in case you calculate for every time, it's not bukan nak spend masa yang panjang kan, kira sikit saja. Once you're expert, you know this is a very quick process.
Oh yeah. Okay, thank you, Madam.
Alright. So Madam proceed untuk yang next part, boleh ke?
Madam.
Yep.
Do we need to write the charge on the Lewis structure?
What charge is that? The overall?
The 0, positive 1 and such.
You mean the outside the bracket one or the formal charge?
The bracket -1 on the carbon and such.
Yes. When if there is non-negative value, then you have to put in.
Oh, we need. Alright.
Yeah. So exactly like what Madam did now. So put it on the structures. Okay.
But yeah, Madam, for the exercises above for the Lewis structure, do we need to do the formal charge?
You can practice on that, but not necessary. You can practice on that.
Okay.
So we can just exclude it, right?
Yes, but make sure everyone know how to calculate. That's the main thing. Nak buat lebih, Madam galakkan. Kalau tak ada soalan ni tak minta. Tak nak buat tak apa. Okay, so the next part, we see what is the time now. 43. Sempat. Okay, so madam will show this one. So for this topic is to use the formal charge. And how are we going to apply the formal charge to determine the most plausible structure? Most plausible means, where the word most plausible means which one is the most stable, which one is the most possible structure. But we are referring to plausible. You are still using the word plausible. So it means which one is the most stable structure, which one is the most possible structure, which one is the most preferable structure. Which one is the preferable structure? Yeah. Okay. So we are applying this one when there is more than one Lewis structure with the same formula. So let's say using one formula, sometimes I come up with three structures. So which one is actually the most stable one? Which one is the most plausible one? So we need to compare the formal charge for all of the atoms inside the structure. Okay, so compare the formal charge for all atoms to determine the most plausible structure. And you have three priority that you need to remember. Following the arrows, first priority go for zero formal charge on all atoms. So let's say you got all the atoms, 5 atoms, all of them are zero. Then that is the number one priority. If don't have, doesn't matter. After you calculated, you compare which structure give you the smallest formal charge. Okay, contoh smaller formal charge. Let's say I have ABC, two of this structure, yeah? Let's say over here I got 0, -1, +2. Okay, over here I have -1, +1, +1. So let's say over here. Overall charge, still the same. They are having a +1 charge. Okay, but the smaller formal charge bukan cakap dia punya individual value. We are looking at the whole set, the whole structure. So in this case, we will prefer this one, the second structure having the smallest formal charge. Because every value is closer to 0 compared to the first one, +2, higher up a bit, so less preferable. Okay, so the second priority, smaller formal charge, refer to the second example here. We want every value closer or lowest. It is the lowest. Okay, and then our third priority, if let's say you have two structures, okay, having the same formal charge, -1, -1, +1, +1, +1, -1, cuma susunan dia lain. So we go for the third priority here. And we need to check, is the negative formal charge located at which atom? So over here, you need to highlight, negative formal charge should be located on the more electronegative atom. So sekali lagi kita comparekan FON, Cl. Tempat pertama, kedua, ketiga, keempat. Yang lain awak ikut trend. Across the period, the negativity increases. Down the group, the electronegativity decreases. So compare lah macam tu. Okay, so see who is more electronegative, then negative charge on that atom is more preferred. Okay, so let's look at this example. We're back to CO2 again. Draw all the possible Lewis structure for carbon dioxide. Determine the most possible structures. So given you the guideline here, number of valence electron. Draw the Lewis structures for all of them, and then calculate, compare the formal charge. So every time when you start this step, we start all over again with the total number of valence electron. Carbon, 4 valence electron. Oxygen, there is 12 valence electrons. Altogether, 16. Okay, so for this type of questions, you need to start with one Lewis structure first. The correct Lewis structures, then only you're producing the second and third structure. Okay, so let's say kita mulakan sekali lagi or the skeletal structure. Carbon, least electronegative, we put in the center. Okay, and then who remember step 4, what should we do? Kita tolak dululah, tolak 4 valence electron. So dekat sini tinggal lagi 12. So next step, apa yang kita kena buat? What is step 4?
Tambah bond.
Tambah bond? Step 4? Surrounding atom must be
Tambah dot.
dot. Surrounding atom must be octet. So 12 valence electron, let's say we placing equally for the oxygen. So now all these 12 valence electrons gone, nothing left. But carbon is not yet octet. So what we are going to do, we borrow one of the lone pair, making a double bond. So making double bond adalah step yang kelima selepas awak letakkan octet elektron dekat oksigen, dekat surrounding. Kalau tak cukup, baru kita buat multiple bond. Okay, so carbon is still not yet octet. Then we borrow one more lone pair. So let's say madam nak borrowkan lone pair daripada oksigen yang sama. Okay, so jadikan dia triple bond. So if you calculate back again, 2, 4, 6, 8, 10, 12, 14, 16. So overall electron dia masih 16 lagi. Jadi semua atom adalah octet. So bolehlah ini Lewis structure adalah betul. Okay, so kita namakan ni structure pertama. Okay, labelkan. This is structure 1. Of course, I can do second and third structure. So imagine over here. Tadi madam cakap saya boleh pinjam lone pair daripada oksigen pertama ataupun kedua. So now if you imagine, if I borrow one of this lone pair, okay, from the second oxygen, and then I push it into the single bond. So kalau madam buat macam ni, maksudnya madam jadikan sini sebagai double bond. So when you push in, carbon only can achieve octet. Lepas tu madam push out satu lagi. So dekat sini madam dapat structure yang kedua. So I show you this way. So originally I have single bond between this carbon and oxygen. So when I push in this lone pair, so it makes me a double bond. The remaining 2 lone pairs still there. Okay, so between the first oxygen and the carbon, initially I have 3 bonding. But now because here I have double bond, on the right side double bond. So now on my left side, I need to reduce to double bond. From triple bond, reduce to double bond. So ini adalah structure yang kedua saya. Kalau kira balik lah, bilangan elektron dia masih sama 16. Okay. So now I'm using another one. Using another lone pair from the second carbon. Warna macam tak nampak ya. Okay. So let's say I'm using another color, yeah. So this is the lone pair. I'm pushing in, I'm pushing out. So the third structure is over here. Oxygen, lone pair is pushed already, right? So double bond becomes single bond. Carbon, double bond become triple bond oxygen. So this is my third structure. Okay. Always start from one of the Lewis structure. Awak boleh start daripada sini, tak ada masalah. You can start from here. You can start from the center one, no problem. But you need to know how to shift the bond. From single bond become double bond become triple bond, or from triple bond reduce to double bond reduce to single bond. Okay, so any questions until this part? Yes? Sorry, madam, tak dengar. Can you repeat one time? Madam tak dengar. Sayang siapa yang dengar cakap ni? Sekejap ya. Madam tengok.
Sorry, madam, can you hear me?
Ke you type dekat part message sana?
Madam.
Ya.
Structure 1 dengan structure 3 boleh dikira sebagai structure yang sama ke?
Dia sebenarnya structure yang sama, cuma arrangement dia lain-lain. Macam mana kita nak tentukan dia sama ada dia structure yang sama? Awak kirakan bilangan elektron total dia. Kalau awak tengok sini 2, 4, semua adalah 16 lah. So over here 16, over here 16, over here 16. The differences is just the arrangement of single, double or triple bond.
So, saya boleh lukis lah.
Ya.
Madam.
Okay. So kalau awak sudah susun sampai struktur yang ketiga, sudah tak boleh pindah kan? Kalau awak pindah, awak akan jadi struktur yang sama balik. So that means there is only 3 structures in this case. Okay. Yes.
Sorry, madam. Isn't it the first and the third structure is identical?
It's identical. It's just different by how you arrange the first bond and the third and the second bond.
So we still need to draw the third one.
Yes.
All right.
Okay. We try a very fast one to calculate the formal charge. Okay. So because time is already 55 now, so let me finish this one first, ya. Boleh kan madam pinjam masa sikit?
Yes.
Like oxygen, help me to find out the first oxygen, the formal charge. 6 minus 2 minus 3. Valence electron 6, right? 2 dots, so minus 2, 3 lines, minus 3. So over here we have, what will be the formal charge for the first oxygen in the first structure?
+1.
+1. How about carbon? 4 minus 4? 0. Oxygen's over here. So including the dot itself, yang warna biru ini, madam nak tunjukkan macam mana dia form second structure. Okay. Madam cuma nak tunjukkan macam mana dia form second structure. So kalau nak kira balik formal charge, masih guna lagi structure yang sama. So 6 tolak 6 tolak 1. So dapatlah -1. Okay, for the second structures over here, 6 minus 4 minus 2 got you 0. 4 minus 4 got you 0. 4 minus 4, 6 minus 4 minus 2 got you to 0. The third structures over here, oxygen 6 minus 6 dot minus 1 line, -1. Carbon is 4. Oxygen's 6 minus 3 minus 2 is +1. So in this case, the most possible structures is go to the second structure. And what is the reason?
Zero formal charge.
Yes, there is a 0 formal charge on all atoms. Okay, our first priority. So comparing to the first and the third structures, the structures number 2 having all 0 formal charge. Okay, so you may also try for the second and the third questions. Then we will discussing on the coming Tuesday. This week, Thursday, we're still having class because your lab period is an empty one according to the CO. So Thursday, we are having the tutorial. Sebab chapter ini panjang ya. Okay, so question number 2 and 3, you try to do it. Then for the coming one, we will complete about resonance structure and then discuss a little bit on the exercises. So I think most of you still having some. So we see what we have completed today. Yeah, Lewis-Strauss structure. Okay, our octet rule and also the exceptions, incomplete, expanded, and also odd electron. We have the stability of ion, noble gas, half orbital, pseudo noble gas. Okay, we have our ionic bond, covalent bond, dative bond. Okay, and then we look at the Lewis structure, the bond length, the formal charge. So for the last two one, resonance structures will be continued on the next hour. Okay, and the last one we have talked a little bit most possible structure. Okay, so it depends on formal charge and also priority lah. So this is a guideline what we have discussing today. Memang untuk chapter 4 ini agak intense. Ini hanya untuk 4.1. 4.2, 4.3 lagi intense. Okay, so I hope everyone can revise back what we have talked today until the part we stop. Okay, and then Madam will explain about the further one in our next hour. Okay, so any questions before we end our class today? Ada soalan? Tak ada soalan?
No questions, madam.
Madam tak ada soalan. Memang kita semua pening. That's why Madam said you have to watch the video. Untuk sesiapa yang memang tak tengok video memang hancur lah.
I watched the video also don't
but still cannot
understand.
get it. Yes, that's why I said please prepare for chapter 4. Memang Madam tahu setiap tahun memang chapter ini very very challenging. Even face to face they cannot get it. I wonder if you are through online, Madam pun kesian jugalah. So we'll see how it's go lah. But make sure you practice Lewis structures, yeah? Okay, so if no questions, then we will start by now. And the homeworks, please send into your Google Classroom.
The one before formal charge, am I right?
Yes,
That's
the
all?
one in template, yes.
A until J, alright.
Okay, so thank you, class.
Thank you, madam.